Howdy, my name is Sapkota, and I'm going to walk you over my poster entitled Mapping Herbicide Drift Injury and Predicting Yield Loss in Cotton Using Remote Sensing Techniques. In this study, we aimed at mapping the herbicide drift injury and predicting the drift caused yield loss in cotton using UAV-based remote sensing. Identifying herbicide affected areas is very crucial for farmers to design contingency plans for better crop management. However, identifying such affected areas manually in the field is a very time consuming process. Remote sensing, on the other hand, could be a better alternative for this kind of work, and that's what we're going to find out in this study. For this study, we used two different herbicides, dicamba, a synthetic auxin herbicide, and temotrine, an SPPD inhibitor herbicide. We simulated a real drift from these two different herbicides. We then established four injury labels and a control plot over the gradient of injury, as you can see in the poster. Within each injury label, we placed 7 quadrats, each of size 50 centimeter by 50 centimeter randomly as the experimental units. We then collected both multispectral 5 bands and thermal imagery using two different sensors, and also collected lint yield at the end of the season from each experimental unit. We use supervised machine learning model to map the injury, which is our objective one, and we use polynomial regression technique to evaluate the ability of remote sensing variables to predict the yield loss, which is our objective two. In figure 1 in the result section, you can see the maps showing the drift caused injury by both herbicides. We had reasonably high mapping accuracies for both the herbicide. However, our remote sensing model failed to detect injuries farther away from the drift simulation transect due to the classification errors. Nevertheless, our model detected high and moderately injured cotton areas which were ill sensitive according to the mean comparison stat that's shown in the figure 3, and this could be much more of a concern to a farmer. Further below, in figure 2, you can see various regression graphs between lint yield loss and cumulative values of remote sensing variables. In particular, vegetation indices are found to have higher prediction accuracies in our study. We are still analyzing images for other drift timings and growth stages. We are hopeful that our mapping accuracies will boost up once we analyze all the images. We had two conclusions from this study. First, yes, remote sensing technique can be effectively used for mapping and estimating herbicide drift caused cotton injury in the field. Second, vegetation indices are better than other remote sensing variables in predicting yield loss due to herbicide drift injury. Thank you for going through my poster, and if you would like to know more about this study, please feel free to contact me. You can find my email address in the poster. Thank you so much.